yes, still have to talk about hoisting, but we'll talk about that very soon. So now let's talk about JavaScript. One thing that you need to know is that JavaScript is um JavaScript is a synchronous programming language or a synchronous language. Now, what does synchronous mean? Now, if you've noticed something, if you are trying to if you say console.log A, console.log B, console.log C, D, E, F, what happens? It arranges it exactly as what printed it out. Meaning that what it waits for one particular program to what complete, move to the next, wait for that to complete, move to the next, wait for that to complete, move to the next. So it's like a top to bottom kind of language. Now, let me show you what happens whenever you try to print out something. Let me use Paint so you can see what I'm saying. So now, taking a look at this now, this is what happens. So let's say I have different projects right here. 2, 3, 4, 5. 5, right? Now, what exactly is happening right now is that there is a stack created. So I'm just going to put this here. Now, there's a stack created that when you say console.log A, B, C, D, E, and F, what happens is that A gets what logged onto the stack, and what happens? It gives you the result. You see it. It moves to the next one, of course, in a millisecond, but this is exactly what happens. Move to the next one, which is B, gives you the result. Move to the next one, which is C, gives you the result. Move to the next one, which is D, then what? E, gives you the result. Now, this is exactly what happens underneath. Even though, although you see whatever happens in a GPU or in a millisecond, that is basically what happens. Now, JavaScript is a top to bottom language. Each task waits for each of them to execute before the next one executes. Let me give us a practical example of what I'm talking about. So I'm going to remove this. Are you done? Okay. You know what? I'm going to create another one. So let's call this sync.js. Now, in this synchronous.js, let me add it to this place. Let me remove this one. Then I'm going to say script source, which is what sync.js. Now, let us go ahead and try what I'm trying to say. So now, if I have let A equals to 10, let B equals to 20, and let C equals to 30. Now, if I say console.log A, and I have console.log B, then similarly, I have console.log C. Do you get what exactly is happening now? All right, now. What exactly is happening now is your call start, you have what? Your output. Now, your output is going to give you what? 10, 20, and what? 30. Now, what just happened now is that what? A got logged first in the call start. After it was executed, it moved towards B. After B was executed, it moved towards C. And that's your call start. That's how it works. Synchronous. But what happens when what happens when a user wants to log in? Right? Two things happen when a user wants to log in. You input your details, click on send. Your current page is loading, right? But no, you want to sign up. Let's say you want to sign up. Your current page is loading, but at the same time, your data are being sent to the database. Those are two tasks that have to execute at the same time. How do you do that if all of these things are what? Top to bottom. That means naturally in JavaScript, two tasks do not execute at the same time. Do you understand what I'm trying to say? Two tasks don't execute at the same time. One task has to wait for another. But now, in a case whereby you now have a user has to log in, input their login, page is loaded, their details, page is loading. Then again, you want to sign up, those details have to be sent to the database. That means two tasks has to work at the same time. How did you now go ahead to create that particular scenario whereby two tasks are working at the same time? Do you understand now? That is where asynchronism comes into play, or asynchronous programming. Now, asynchronous programming is that phenomenon whereby do not allow multiple tasks to run concurrently or run at the same time. You understand it now? Now, one thing is that you are just creating a particular logic that just tweaks the synchronism and makes it look as if, okay, everything is working with synchronously. Now, this is what I'm saying. You are running asynchronous code, but you have to trick JavaScript to make it think it is running what? Synchronously. Because naturally, JavaScript works as what? A synchronous program or a synchronous language. Now, that is what synchronous and asynchronous is talking about. Now, this is a popular synchronous, as you can see, a computer program is made up of tasks that the computer executes one after the other. In JavaScript, these tasks are divided into two types. One, synchronous, other is what asynchronous. Synchronous run one after the other in the normal order. Now, the next task cannot start until the previous one finishes. And this is called a blocking execution. You understand it now? So, for instance, let me give an example. What if I want C to run before B? Right? What if, okay, I'm trying to make sure that, okay, my C runs before B. How exactly am I going to go ahead to do something like that? Now, I can use what? Asynchronous programming to run something like that. Now, one thing that I will always use, or everybody will always use, is using set timeout. Now, when we have set timeout is a function, right? But it's an asynchronous function. It's an asynchronous function because you can use it to delay certain tasks and wait for other tasks to run, or run two tasks at the same time. So as set timeout is running, other tasks are also what's running. For instance, let's say let D equals to what? 40. Let E equals to what? 50. Then let F equals to what? 60. Now, what if I want to have 40 come first, 60 come second, then 50 come last? What can I do? I can use set timeout to delay 50 while other ones are running. Now, one thing is that what the 50 is running, right? But just because it is delayed, you will not see the result until a particular amount of time has elapsed. Now, how do you use your set timeout method or function? You have what? Set timeout. This is how you have it. Then, of course, an arrow function. Then you're going to have something like this. Now, I can now say console.log and have E. Why? Because I want it to run. No, I can. Okay, let's bring out console.log D. You understand? Then I can also have what? Console.log F. Now, I cannot set. Sorry. Okay. Yeah. So it's E. Now I cannot set the amount of seconds it's going to have. Let's say I want it to run for 2 seconds. Now this is 2,000 milliseconds. This is under the milliseconds. 2,000 milliseconds for 2 seconds. So now what's going to happen now is that what? D is going to run immediately, and F is going to run immediately. Now this is D runs, right? And F runs immediately after D. Now, E has to now wait for how many seconds? 2,000 seconds to run. Meaning that what? Even though the natural order is D, E, and what? F, look at this at top to bottom, right? D, E, F. E is still going to wait for a particular function to complete before the order works. That is asynchronous. So if I save it now and I check this out, what do I have? I'm going to have what? So 40, 60, then what? After 2 seconds. Do you get it now? Now that is asynchronous programming. All of those tasks are running together. But what is happening? One has to wait because of a particular timeout. Do you get it now? Now this is how it works. This is how something like this works. So you have D, you have E, and then you have F. Now for them to run, this is exactly what happens. You have D come first. At the same time that D is coming, you have what? E. Why? Because E is independent of what? The D that is there. Now you now have what? F. Now F now runs after what? This D that is here. Now this is exactly now what happens. The result now brings what? E. Sorry, this D, D, F, and what? E. But this E was logged into the stack at the same time with what? With D. You know, before in the synchronous was A, B, C, D. But in this kind of it was E immediately was come, but because of what the delay that is happening, and because the program is running, what happens? It's not going to come last. That's exactly what is happening. That's your call stack. So basically, what your asynchronism is talking about was that you can run multiple tasks at the same time. And one thing is that as you can see, it is behaving as if it is a what? A synchronous project of 1, 2, 3. But because of the trick of asynchronism, what happens? It tricks JavaScript to think, oh, this is a synchronous program. But in the end, it's actually what asynchronous, so that you can have multiple programs on the same time. You can do the same thing. Now, this is not the end of asynchronous programming. You have a lot of things that I have to talk about also in asynchronous programming. So a lot of what's the name? Examples to give in asynchronous, but I need to know if we all understand what this is. Do we understand it? Is it clear to everybody? All right. Now let us have another example. Let's say I change this now to 0. Please tell me which one comes first. Which one comes first? E, F. Okay. 0. So 0 seconds now. Mr. Victory. Same thing. See? 0 milliseconds is still 0 seconds. Why?
We already set a time for E. So the number of segments F point.
But it's 0 now. So it's no matter.
Segments of that. Each should have that for segments. But here, if you show immediately, was beyond that level.
Very, very good. That's actually the answer. Now, the thing about asynchronism is that it is not immediately. Do you understand it now? You have D, first of all, comes. Immediately D what F comes instantly. Then after F, your E comes under it. Why? Because again, the call stack is a very important feature. Do you understand it now? It is locked in seconds. So if you check it out now, what do you have? So as you can see, it was immediately, right? But 40, 60, and 50. Immediately. Do you get it now? So it has to be below. Do you understand? Because one thing about your D and F, they are immediately very fast. 1, 1. But that particular set timeout is actually a program that runs independently, doesn't really work for us. So there's every tendency that it is slower to react because why it is independent. You understand? Now that's one thing about what set timer. Now let's have another example before we move on to like a much more difficult example. So let's have multiple timers. So let's say console.log. Let's have task 1. So we want to have multiple timers. Task 1. Now we're going to do the same thing with this. I'm going to set timeout, right? Then of course arrow function again, right? Now we're going to have console.log task 2. The same thing. We're going to set timeout again. Then I want to have multiple timers. Then we're going to have what console.log task 3. Then again the same thing, task 4. Okay, let's just leave it like this, task 4. Now, what do you think you're gonna have? Hey, give me the expo. But why did you say it? Some of us, I know some of you said it. Did you see the expo? What's gonna be the outfit? Just what time was gonna be the outfit? What's the output? So this is where it started from. You know, let me give it space so you can see it. Task 1. Yeah, let me add 0. I need to add 0 to it.
task 1, task 2, task 4.
That's going to be the answer. Please look at it again. Look at it again. I did. Task 1. Why not task 1, task 4, task 3, task 2? So let us check it out. So now, task 1, task 4, task 2, and what? Do you understand it now? Now that is the, and as you can see, even this 50 ran after, because this is a what? Asynchronous. After this task 1 and task 4. Do you get it? Now this is one of the ways in which you can what? Create asynchronous programming with set timer. Now again, this is the basics. This is the mini basics. Now let me take us to a reason where a place whereby we can now like talk about something much more. You know what? I don't want to rush us in asynchronous programming, but there's something we call a callback error. And I'm going to take us to that particular callback error. Now let us nest a, let me look for what's to use. Now let me nest all of these things inside of a particular set timer. Now let's try something out. Let's say you want to order food, right? Multiple asynchronous program that are all nested into something, ordering food. Because the major things that you want to order food, that's why they are preparing food. Now let us have like something whereby they are all nested. So let's say let's just go ahead and have something. You can say console.log, right? In this side, we can now have what ordering food, right? Now, while you're ordering food, you want to have a set timeout. You just have this set timeout function, right? Now, in this particular set timeout, you now want to be able to what? Order food. So we're gonna have the first one, console.log, what food is ready. Do you understand? Food is ready. Now in the timeout, let's give it 5,000 seconds. Sorry, 5,000 milliseconds. That's what 5 seconds, right? Now, inside of this thing, well, no, let's say food is not, let's say food will be ready in 5 seconds. Now, while food is trying to get ready, right? Let us not say, oh, but we have snaps to give to you. We have another set timeout. You can say set timeout. Set timeout. You can say, well, you're gonna eat snacks in 2 seconds, so 2,000 milliseconds. So we can now say console.log take this snack while you wait. Good. Take this snack while you wait. Now, you can also have another word, callback. As you're taking that particular snack, you can now have a word. As you can see, all of these things are what? Nested inside each of them. You can now have, that's how many seconds is it? 3 now. So you can now say another set timeout. Let's say set time at 3,000. Okay, it should be 1. I mean, let's say 1,000. Yeah, 1,000. Or let's give 3,000 milliseconds. Now, we can now say console.log food is ready, enjoy your meal. Now, check what happens here. If you check out the output, so I'm gonna save it. Now, what exactly is happening here? You're ordering food. Food will be ready in 5 seconds. Take this snack while you wait. Then last one, food is ready, enjoy your meal. Now, see how all of them came one after the other. Refresh. You're ordering food. Can you see the ordering food here? Okay, let me remove other tasks so that we can have access to only that one. Don't worry. I'll just comment it out. It's not. So now let's look at it. Ordering food, move on to the next one. After food will be ready in 5 seconds. Okay, take this snack while you wait. Then food is ready, order your meal. Now, I want us to count it. After this ordering meal, let us check if this thing runs for actually for 5 seconds. 1, 2, 3, 4, 5, 7. Do you understand it now? We wanted it to run in how many seconds? 5 seconds. See it. That was the initial distance for all the ordering food. We wanted everything to run in 5 seconds, but it took longer. Now, that is what we refer to as what? Callback hell. So callback hell is basically when you would have nested callbacks, so it becomes difficult to what? Maintain the code, and this is often referred to as a callback or pyramid of doom. And it's a pyramid of doom, or let me leave that pyramid of doom. Callback hell, because one thing is that first of all, your code is what? Is not neat. Look at this. See it. Your code is not what? It's not neat. That's the first thing. It is not neat. Secondly, it can take longer than you actually was expecting. That is why you see that you go on some pages and pages are loading. 20 seconds still loading. That's bad. And as opposed to other pages, you go to other pages, 5 seconds, 2 seconds, they are automatically loaded. Do you understand now? Now, that is one thing about what? Your callback error. Now, one way you can use preventing these callback errors or having all of these things is to use what? Is to use these 3 methods. Now, the first method is your callback functions, right? Other method is what? Promises. Then the last one is what? Async and await. Now, these 3 things will now help you what? Stop all of these callback errors. Although you can say have callback errors if you are not careful. But they help you structure your code to make sure that what you can now intentionally avoid callback errors. Okay, I hope everybody has been hearing me since, because I just noticed now that first of all, my camera was off. Mr. Shem, can you hear me, please? Let me see if they sent me a message on WhatsApp. All right, good. So my camera is just, I don't know why it's going off. Okay, so all right, so let's continue. Now, that is basically what your callback error is. Again, your callback error can now be avoided using these 3 things. First is what? The callback function. Then you have your what? Promises, and then you have async and await. Now, when we talk about callback functions, I don't want to go into giving it this definition. But basically, when you talk about callback, you are passing an argument. You know, back then, it's as if you are passing functions as parameters into another function. So now, instead of having things like this, instead of having this, you cannot create a function. Now, since you want to make sure that all of these things wait for 5 seconds, you can now pass each of all of these things as functions into the what's the name? Into the parent function. Now, for instance, this is the parent function, right? Which is ordering food. You understand? Now you can now pass these ones as a parameter, functions or parameters into all of the other functions. That's why they call it the callback. You're calling it again as a function. Yes, you passed as a parameter before, but later you call it as a function to perform specific actions. Now that is one thing about your callback. Now, in our next class, we will talk about callbacks in detail. Callback, promises, sync and await in details. But for now, I'm going to go ahead and talk about something else. Probably give us time. One or two things. Probably give us time. But before then, let's just go ahead and write this down, and then I'll talk about give us classwork, and then we'll move into callbacks in our next class. Any question, please, so far? I need to know if you understand today's class. Is it clear to everybody? Is it clear to everybody?